Today we will discuss about the structure of the atom. Atom and molecules are the fundamental building blocks of the matter. In this chapter we will study about the subatomic particle. We will discuss about the subatomic particles and various models that has been proposed to explain how these particles are arranged within the atom. It was known by 1900 that the atom was not a simple indivisible particle but contain at least one subatomic particle, the electron, which was identified by the J.J. Thomson. J.J. Thomson discovered the subatomic particle electron. Even before the electron was identified, E. Goldstein in 1886 discovered the presence of new radiations in a gas discharge and is called them as the canal rays. These rays were positively charged particles which ultimately led to the discovery of the another subatomic particle. This subatomic particle has a charge equal in the magnitude but opposite in sign to the electron. Its mass was approximately 2000 times as that of the electron and it was given the name as the proton. There are the three subatomic particles in the atom: proton, electron and neutron. Proton carry positive charge PP. Proton P positive charge. Electron carry negative charge. Neutron is neutral. It has no charge. Proton is represented by the P. Electron is represented by E. Neutron is represented by N. Mass on the proton is 1.67 into 10 is to power minus 27 kg. Mass on the electron is 9.1 into 10 is to power 31 kg. And mass on the neutron is 1.675 into 10 is to power minus 27 kg. And proton and neutron collectively called as nucleons. Now the structure of the atom. We will discuss about the structure of atom. For explaining this, many scientists proposed various atomic models. J.J. Thomson was the first to propose a model for the structure of the atom. Thomson model of atom. Thomson proposed the model of an atom to be similar to that of a Christmas pudding. It was like a Christmas pudding or a cake. The electrons in a sphere of the positive charge were like the carrots or the dry fruits in a spherical Christmas pudding or cake. In the cake, dry fruits are spread here and there, and just like the electrons are spread here and there in the atom. We can also think of the watermelon. We can also take the example of the watermelon. The positive charge in the atom is spread all over like the red edible part of the watermelon, while the electrons are studied in the positively charged sphere like the seeds. Seeds are just like the electron that are spreaded in the watermelon, and the red edible part is like the protons, while the electrons are stored in the positively charged sphere. Thomson proposed that an atom may be regarded as a positively charged sphere. Thomson told that an atom may be regarded as a positively charged sphere in which proton present. Atom is the positively charged sphere. Atom is the positively charged sphere and in which proton is present in sphere. The negatively charged electron may be regarded as studied or embedded in this sphere, and the negative charged electron is embedded here and there in this sphere. The positive charge due to the protons and negative charge due to the electron balance each other. As a result, an atom as a whole is electrically neutral because there are also the negative charge and this red edible part carry the positive charge, and it is electrically neutral or it has no net charge. Now, what was the limitations of the Thomson model? It could not explain the result of the Rutherford scattering experiment. It could not explain the result of Rutherford scattering experiment. It did not have any experimental evidence. experimental evidence in its support. Now next model is Rutherford model of an atom. Rutherford model of an atom. Ernest Rutherford was interested in knowing how the electrons are arranged within atom. Thomson said electrons are spread just like the seed in the red edible part here and there, but Rutherford wanted to know that how the electrons are arranged within the atom. Rutherford designed an experiment for this. He performed the experiment, but Thomson did not perform the experiment. In this experiment, fast moving alpha particle he used the alpha particle were made to fall on a thin gold foil. He used the thin gold foil and the alpha particles. He selected a gold foil because he wanted as thin a layer as possible. This gold foil was about 1000 atoms thick. Alpha particles are doubly charged helium atoms. These are the helium ion. Since they have mass 4u, the fast moving alpha particle have a considerable amount of energy. It was expected that alpha particle would be deflected by the subatomic particle in the gold atom. It was expected. What was expected? That alpha particle would be deflected. Alpha particle would be deflected by the subatomic particle in the gold atom. Since the alpha particles were much heavier than the protons, he did not expect to see large deflection. There must be deflection at some extent but not large deflection. But the alpha particle scattering experiment gave totally unexpected result. The result was so unexpected that Rutherford never think about it. What was the observations of the Rutherford experiment? Most of the alpha particle passed straight through the gold foil. This is the gold foil, atom of the gold foil. And when he bombarded alpha particle over it, then he saw that some of the alpha particle go straight without any change. Most of the alpha particle pass straight through the gold foil. Some of the alpha particle were deflected by the foil by a small angle. Some were deflected by the small angle. Some go straight, no change. Some show some deflection. Surprisingly, 1 out of every 12,000 particles appear to be rebound and very small amount rebound in the same direction or at the small angle. Conclusion. What was the conclusion of the Rutherford atomic model? Most of the space inside the atom is empty. He said that most of the space in the atom is empty because most of the alpha particles pass through the gold foil without getting deflection. Very few particles were deflected from their path, indicating that positive charge of atom occupies very little space. Where the positive charge present, then there they show the deflection or show the rebound. A very small fraction of alpha particle deflected back, indicating that all the positive charge and mass of the gold atom were concentrated in the very small volume within the atom. Now, what was the feature of the model? Feature of the Rutherford atomic model. There is a positively charged center in an atom called the nucleus. In the center, there is a positively charged particle present and this is called the nucleus. Nearly all the mass of an atom resides in this nucleus and mostly mass is present at the nucleus. The electrons revolve around the nucleus in the circular path. Electrons are revolving around the nucleus in the circular path. The size of the nucleus is very small as compared to the size of the atom. What was the drawbacks of the Rutherford model? Rutherford model was rejected. J.J. Thomson model was rejected, but Rutherford model was also rejected because it could not explain the stability of the atom. stability of the atom could not explained by the Rutherford. This is because electrons revolving around the nucleus must lose energy continuously in the form of electromagnetic radiation. Therefore, the motion of electron will slow down and ultimately it will spiral down into the nucleus. That is, atom must collapse, but actually atom is stable. It said that electron loses energy and slowly fall down into the nucleus, but actually atom is stable. This was not the right concept. Atom is actually stable. It could not explain hydrogen spectrum. Next was the Bohr model of atom. In order to overcome the objections raised against Rutherford model of atom, Niels Bohr put forward the following postulates. Bohr said only certain special orbits known as discrete orbits. Special orbits are called the discrete orbits of electron are allowed inside the atom. While revolving the discrete orbit, electrons do not radiate energy, but Rutherford said that electrons radiate energy continuously. These orbits or shell are called the energy shell. These were the energy shell. Energy level in an atom are shown as this K, L, M and N, in which N is equal to N is equal to 1, L N is equal to 2, M shell N is equal to 3 and N shell N is equal to 4. These orbits or shells are represented by the letter K, L, M, N or the numbers 1, 2, 3, 4. The energies of the various shells are in the increasing order. Now the neutrons. J. Chadwick discovered another subatomic particle which had no charge and a mass nearly equal to that of the proton. It was named the neutron. Neutrons are present in the nucleus of all atoms except hydrogen and it is represented by the symbol N.